We're so excited to show you SwiftUI, a revolutionary new way to build better apps faster. We think the best way to learn about SwiftUI is to see it in action by building an app. Using SwiftUI feels like magic, but to make it clear that I don't have anything up my sleeves, I want to go through the entire process of creating an app in SwiftUI starting from scratch. So what kind of an app are we going to make? Well, let me set the stage for you. Anybody here hate meetings? Yeah? Well, so do we. But Kyle and I have found something that makes meetings more bearable, and that's having them in amazing, fancy conference rooms. So we've been making a list of all of the best conference rooms that we can find, and we want to make an app for it. So let's dive in. OK, I'll start by creating a new project, and we'll call it Rooms. And I'll make sure that Use SwiftUI is checked. Now, Xcode has started us off with a view, with the view that we can use to start building our UI. Our code is over here on the left, and on the right is the canvas. And if you're familiar with Interface Builder or storyboards, you may think that there's nothing new here. Some code on one side and a visual canvas on the other, right? Well, there's a very important difference. With storyboards, you need to choose between creating the benefits of using a visual editor or the benefits of creating your UI in code. And if you choose one and change your mind later, then you have to start all over again. But with SwiftUI, that problem is gone. Now, your view definition is always Swift code, and you can always choose to edit the code directly or to use the visual editor, and you can always go back and forth. So if we select something in the canvas, then that selection is reflected in the code as well. And if you change something in the code, then that change is reflected in the canvas as well. They work together seamlessly. So let me tell you a little more about how it works. The canvas shows us previews of our view code, and it even helps us edit and learn about that code. Xcode shows these previews by compiling our real code and running it to generate a result. But one of my favorite things about previews is that they're also created using SwiftUI code. In this case, the code right here. And later on, we'll see how that gives us a lot of power to customize our previews. Now, our app is going to show a list of conference rooms. So let's make the cell for our list. I'm going to add another piece of text under this one to show more detail about each room. And I'm going to add it by just dragging it out onto my canvas. And Xcode even shows me what will happen when I place it at different locations. Now, when I drop it in, the preview updates to show my new text. But even better, Xcode has actually edited my code to add that text. Xcode has embedded these views into a VStack to get the layout that I want. Now, a VStack, or vertical stack, is one of the common layout elements in SwiftUI. It lets you stack views vertically. And there's also an HStack that stacks views horizontally. And these stacks are containers. I can place any views that I want inside of them. Now, I'm going to replace this placeholder that Xcode has given me with some more information about the room. We'll show the number of people that it can hold. And for now, let's just use a hard-coded value. Next, let's add an image next to our text. I can make edits in the code just as easily as in the editor. So let's embed our view in an HStack. I can command-click on my view and choose Embed in HStack. And Xcode has updated the code to do just that. Now, I can add an image next to my VStack. We'll add some assets in a bit, but for now, I'll just use an SF symbol image to get something up and running. SF symbols are new in iOS 13. They're a rich set of Apple-provided images that you can use in your app. And already, we have a basic version of our cell. Now, I'll use the canvas to style the cell the way I want. I can command-click on my stack and choose Inspect to see some of the properties that I can change for this stack. I'm going to set its alignment to be leading. And once again, Xcode has updated my code to make that change. Now, I can also command-click on my text to inspect that as well. And let's change this to be a smaller font. I'm going to use subheadline. And one of the great things about Xcode modifying my code is it helps me to learn about SwiftUI. For example, here, it's added this code to change the font. We call these kinds of methods modifiers, and they're used in SwiftUI to customize the way your views look or behave. I'm going to add another modifier in code to set the foreground color to be a secondary color. OK, now that I have my cell, let's put it into a list. To do that, I'm going to command-click on our cell and just choose Convert to List. This wraps my cell in a list and shows 5 iterations of it. This command. Now that I have my cell, let's put it in. OK, now that I have my cell, let's put it into a list. To do that, I'm going to command-click on our cell and just choose Convert to List. This wraps my cell in a list and shows 5 iterations of it. It's great to be able to do this so easily. And this code is all that I need to show a list in my app. There's no delegates or data sources necessary, just views inside of a list. Next, let's hook this up to some data. I'm going to drag in some assets and a model file that I created earlier. Now, my model has a field of information that we'll use. And to use this in a list in SwiftUI, I just need to make this type identifiable. This lets lists know which items are coming and going. And all I need is an ID property, which we already have. Now, this model file also includes some test data that I can use for debugging my app. Now, let's go back to our view, and let's pass in our data. I'll add a property for my rooms. And one of the great things about previews is that they can use their own test data. So I'll just pass in my test data right here. Now, you may have noticed that this banner appeared above my preview. When I make larger changes to my types, like adding this rooms property to our view, Xcode pauses the previews until I'm ready to have them resume updating. And I can just click this button to resume. Next, let's use our data to drive the list. We'll pass in our rooms to the list. And then I'll update our text to show the room's name. And we'll also use the real capacity right here in our text. And now that we have real images, let's also use our room's thumbnail for the image. Great. And you may have noticed a subtle change that happened to our list when we did this. When we started, our cells were the standard 44 points tall. But when we changed to these larger images, the cells automatically expanded to make sure those images fit without any extra work. It's pretty cool. And now that I have these images in context, they look a little bit sharp. So let's add a corner radius to our images using another modifier. Sharp. For image start for the image. Let's see right here in our text. And now that we have real images, let's also use our room's thumbnail for the image. A little change that happened to our list when we did this. To these larger images, the cells automatically expanded to make sure those images fit without any extra work. It's pretty cool. And now that I have these images in context, they look a little bit sharp. So let's add a corner radius to our images using another modifier. And if you're not sure about what modifiers are available, you can view and filter a list of them right here in the library. Let's find corner radius, and we'll just drag it onto our image. Then we can tweak the values. That looks a little bit too big. Great. And now that our cells and our list are looking good, the next thing that we need is to be able to tap on a cell to see more details. To support this, let's wrap our list in a navigation view. See more details, and our list are looking good. The next thing that we need is to be able to tap on a cell to see more details. To support this, let's wrap our list in a navigation view. A navigation view shows a navigation bar and also has a stack to push views onto. Let's also set a navigation bar title, and we'll just use some text that says rooms to show rooms in our navigation bar. Now, let's set up our cell to push onto this stack. To do that, I'll wrap our cell's content in a navigation button. A navigation button takes a destination, which is a view that it'll push onto the stack. And to start with, we'll just use some text that shows the room's name. Then we'll put all of our cell's content inside of that navigation button, and we're ready to go. And notice that our UI has updated to automatically show these UI indicators. SwiftUI handles details like this for me automatically, so that my UI automatically looks right by default. Now let's also check that the cell behaves correctly. I can just click on this play button in my preview, which takes me into live mode. And when I do this, Xcode is compiling my code, sending it over to the simulator, running it for me, and showing the result of all of that here in the canvas, which means I can interact with my view. So I can tap on a cell to make sure that everything pushes and pops as I expect. And if I swipe to pop, you'll notice an advanced behavior that SwiftUI has given me automatically. Our cells stay highlighted, and as I swipe, they interactively unhighlight it without us doing any extra work. OK, so we've got our list, and it's working with its cells. But this view code is a little bit large now. And I'd really like to factor the cell out to be its own view. And Xcode helps me do this with one simple operation. I can just command-click on the view that I want and choose Extract Subview. It's fantastic. All of my view code gets extracted out down here, and I even get to choose the name for my new view. Let's call it Room Cell. Thank you. Now, let's also add a property for our room. And we'll pass it in right here. This is a fantastic workflow improvement. And with SwiftUI, views are really lightweight, so you don't have to worry about creating extra views to better encapsulate or separate your logic. OK, next, let's build our detail view. I'm going to create a new view and make sure to use the SwiftUI template. And let's call this new view Room Detail. Xcode has automatically given me a new view struct and also the preview code to create it. Now, since I want this detail view to show more information about my room, I'll add a property for the room. And just like I did before, I'll update my preview code to pass in one of our rooms from their test data. Then let's build our UI. We'll use an image, and we'll show the room's image name. OK, now we're showing our image, but it's a little bit too large for our view. By default, SwiftUI shows all images at the size of their contents to prevent visual artifacts from scaling the image up or down. But for photos like this one, we want to be able to resize them down, and we can use an image-specific modifier called resizable to do that. So I'll just drag this onto our view. And all right, now it's resizing to fill the size that we have. But really, we want it to maintain its original aspect ratio. And we can do that with another modifier, this time aspect ratio. And the aspect ratio modifier lets me choose between .fill, which expands the image to take up its entire frame, or .fit, which makes sure the image fits within the frame. And previews let me really easily see and understand the difference between these different modes. For now, let's use fit so we can see the full image. Now, let's go back to our list and update our cell to push our new detail view. We'll create our room detail view, and we'll just pass in the current room. Now, I'll switch my preview back into live mode. And I can tap on my cell to see our image. But now that I'm previewing it here, I can see that I forgot to set the title in the navigation bar. So let's go back to our detail view and fix that. Just like before, I can use the navigation bar title to set our title. And we'll pass in our room's name as the title. But in the preview that I have here, we're only seeing the view itself. And I'd really like to be able to quickly verify my change. Well, since previews have all of the power of SwiftUI's views available, we can do just that. I can set up my preview to be inside of a navigation view using the same code that I would anywhere else. And now my views preview is inside of a navigation bar. And now that I'm seeing it here, this large title looks like a little bit too much for our detail view. So let's update our navigation bar title to set the display mode to be inline. Much better. Now, when I'm picking a good conference room, there's one thing that's very important to me. The room has to have a good table. I just can't focus on what anyone is saying if the table isn't of the highest quality. And I can see that there's some kind of table in this room, but I really can't see its details well enough. But when the image was in fill, I could see it nice and close. Look at that wood grain. So I'd like to be able to change back and forth between fill to see the details of the room and fit to see everything at once. But how do I actually change this aspect ratio's content mode from within my view? Well, to understand how to do this, we really need to know more about how views work in SwiftUI and why. And so I'm going to invite Kyle to the stage to talk about that. Kyle?
Well, hello, WWDC. What does everyone think of SwiftUI so far? Yeah, I'm pretty excited too. It's a little magical though. And so before we go any further, we're going to take a step back and talk about the way views work and why in SwiftUI. So we left off here implementing room detail view. In SwiftUI, a view is a struct that conforms to the view protocol rather than a class that inherits from a base class like UIView. This means your view doesn't inherit any stored properties. It's allocated on the stack, and it's passed by value. Room detail just stores a room, so it's the size and weight of a room. No additional allocation or reference counting overhead. Behind the scenes, SwiftUI aggressively collapses your view hierarchy into an efficient data structure for rendering. Because of this, we make liberal use of small, single-purpose views in SwiftUI, and you should too. What I want you to take away from the last couple slides is that views in SwiftUI are incredibly lightweight. As Jacob said, you should never hesitate to refactor your SwiftUI code because extracting a subview has virtually no runtime overhead. Yeah, you can clap for that. It's pretty great. So a view in SwiftUI and a view in a traditional UI framework fulfill the same primary role. They define a piece of UI. The view protocol only has a single requirement, a body property, which is itself a view. You build bigger views in SwiftUI by composing together smaller views. We built room detail by composing together image, a view of an image at its native resolution, resizable, which opted it in to stretch in either dimension, and aspect ratio, a view that proportionally scales its child. The rendering of any view you build is just the rendering of its body. So if you set a breakpoint and the debugger stops there, it means the framework has decided it needs a fresh rendering of your view. Ta-da! All right, so the framework knows when to fetch a new rendering of a view because in addition to defining a piece of UI, in SwiftUI, a view defines its dependencies. Let's extend room detail to allow the user to tap to toggle between fitting into and filling up the available space so Jacob can get a good look at that wood grain. So the first thing we'll need is a property, but it's a special property. It's a state property, and it says whether or not the image is zoomed. When SwiftUI sees a view with a state variable, it allocates storage for that variable on the view's behalf. In this memory diagram, the green is your app's memory, and purple is the memory SwiftUI is managing. And so this value of the zoom variable, we got you covered. So if you decide to fill or fit based on that variable, then we've got a view that renders like this when it's zoomed, and like this when it isn't. So now all we need is a tap action to toggle back and forth between the two states. And then, on tap, the image will zoom to fill and shrink to fit. So what actually is happening when we tap here? Well, one of the special properties of state variables is that SwiftUI can observe when they're read and written. Because SwiftUI knows that zoomed here was read in body, it knows that the view's rendering depends on it, which means when the variable changes, the framework is going to ask for body again, using the new state value. So it can refresh the rendering, this time with a different content mode. So traditional UI frameworks don't distinguish between state variables and plain old properties, but I've found this distinction to be incredibly clarifying. In SwiftUI, every possible state your UI might find itself in, the offset of a scroll view, the highlightedness of a button, the contents of a navigation stack, it's derived from an authoritative piece of data, often called a source of truth. Collectively, your state variables and your model constitute your source of truth for your entire application. Earlier, I mentioned that this call to aspect ratio makes a view. Its definition looks something like this, where content mode is a plain old Swift property. You can neatly classify every property as state derived variable mode and AI value. See an example in this talk, but Swift gives you a route so you can use data and takes data. For creating, the view needs to, that's a bug. Line is one of the views in your app. What do people think the difference between those two dots is? Anyone? Those are the bugs, yes. So as we add features, the number of possible orderings we have to think of increases. It's inevitable. We have reached for a way to collect all your view, all that one. Well, SwiftUI adding and removing a view. We've spent all the time and done all the work, and we've codified has a single requirement, body, a single entry point that the framework calls. That means there's only one possible order it can ever get called in. Because of this pattern of simply fetching new views for the parts of the UI that changed, SwiftUI scales with your brain, virtually eliminating UI inconsistencies. All right, let's get back to the demo and finish the room detail view. Jacob?
OK, let's finish this app. Now we know how to set up our view to zoom in. We'll add a state property, and we'll call it zoomed, and we'll default it to false. Then, in our aspect ratio, we'll use the zoomed property to change between fill when we're zoomed and fit otherwise. And finally, we'll add our tap action to toggle that zoomed property. Now, let's try it out in live mode. Great. We can switch between these two different modes. But there's something missing here. Does anybody see it? That's right. It needs an animation. And with SwiftUI, animations are really easy to add. I can just wrap my change in a call to with animation. And now, my change is animated. And not only that, the animation is fully interactive and interruptible. So I can always change between the different states, and it always ends up in the right place. Yeah, it's great. Now, I would add the Enhance button next, but it turns out that the way Kyle trained the model, it only ever worked on that one image that he showed. So I'm going to add something more useful. One of our coworkers is in London, so we often want to know which rooms have video conferencing. So let's show an icon for that on top of our detail view. I can use a Z-stack to show views stacked on top of each other. So I'll put our existing image inside of that Z-stack, and then I'll add another image to show an icon for whether the room has video or not. I'll just use a symbol image, and we'll use video.fill. OK, we have our icon here, but it's a little bit small. But symbol images automatically use the current font to size themselves, so I can easily change to a larger font with a modifier. We'll just drag this into our code and apply it to the image. Entitled sounds good. Now we've got our larger image. Next, I want this image to be in the top left. So let's set our Z-stack's alignment to be top leading. OK, next, let's add some padding so that this is not up against the edge here. Again, we can use a modifier to do this, and we'll just drag it in onto our system image. And all edges seems like a good choice here. OK, this is close, but I really want to have this icon all the way at the top of our view area. And we can get our video icon there by putting our room image inside of a flexible frame. The frame, its content, and we'll use more. Makes that really easy. We can just use an if. So we'll add an if, and we'll check whether our room has video. And we'll only show our image when that's true. Now, we can check if this is working by changing our preview data to a room that doesn't have video, which is nice. But even better, we can actually set up our previews to show multiple versions of our views at once. To do that, I'm just going to embed this view inside of a group. And now I can have multiple views here. So let's create a second version using different test data. Now we have one version of our view with video conferencing, and another version without. Now let's go back to live mode. Now, when I'm in the zoom state, having that icon on top of my image is a little distracting. So let's update it to also disappear when we're zoomed. And we can do that just by updating our condition. Now, the icon automatically shows and hides as we zoom in and out. But even better, it animates, fading in and out. And we can also customize that animation behavior by setting it to a different transition. So let's try .move, and we'll use the leading edge. Now our icon slides out and slides back in. And let me also make this a longer animation by specifying a custom animation with a duration of 2 seconds. Now we can see our animation in going. Pairing this aspect finishes action time. Finish the data in our abstract. And all we need to import your data to a notification that we take you through to tell SwiftUI that our list also room. When I tap it, we get our new room. Great. Right next to all of our data. And when I tap it, we get our new room. Great. So just like that, we were able to add this single static element combination there. Then we sheet the rows. This for each is now configured to call into our back, call it the way we set. There it is, and we'll move it on our list without us having to do any extra work. Yeah, that's cool. And of course, now we can drag to reorder. Let's saw how we can modify all the lists. It's just work we need to do. And this time, we're going to higher chain text. Finally, let's also see how our app works with other languages. And once again, it all just works. So let's add another version of our view and update the environment to set its color scheme to be dark. And once again, it all just works. And finally, let's also see how our app works with other languages. I have some English string files that I'll drag into my app. And I'll tell Xcode to localize them. Then I'll go to my project file, and I'll import a localization that I have for Arabic. Now let's go back to our view and add one more preview. Then I'll go to my project file, and I'll import a localization that I have for Arabic. Now let's go back to our view and add one more preview. Now, if we first set the layout direction to be right to left, we can see that this automatically works without any extra work. But if I also set the locale to be an Arabic locale, you can see that everything gets localized. And even better, if we look back at our code, we didn't do anything extra to support these features. To get our text localizable, we didn't have to mark up which strings should be localizable or not. SwiftUI automatically infers that. For text using string literals, it's localizable by default. And for text that's created by getting past a string, it defaults to getting used as is. This means that all of our app text, like rooms and add room, gets localized. But all of our content, like these room names, still gets passed right through. But even better, you can finally use string interpolations and have them localized correctly. I love string interpolations. They're great. We're really excited for you to start building apps with SwiftUI. When you get all of these behaviors for free, you can concentrate on the unique parts of your app and build better apps for your customers even faster. Now, we built an iPhone app here, but you can use these same APIs and techniques across all of Apple's platforms. And you'll get these kinds of automatic behaviors across all of them. OK, let's take one last pass through our app to review what we built and make sure everything is working right. I'm a big fan of dark mode, so let's use that version. OK, we have our list of rooms, and we can tap on one of them to see more information. And in our detail view, we can tap to zoom to full screen, which hides our video icon with a transition. And that animation is always interactive. And we can also edit our list to make changes. Let's move this one down. And I don't think anyone really wants to use the dungeon conference room. Actually, I'm also not sure why Kyle added this room that has an elephant. Let's get rid of that one, too. Let's add our conference room. Great. That's our app. But there's one last thing that I want to point out, and it's something that we didn't see. We just built up this entire application and tested all these rich behaviors without ever once building and running our app. Xcode previews let us view, edit, and debug our application way faster than was ever possible before. So thank you very much. I hope you enjoy using SwiftUI as much as I do.
Hi, my name is Grant. I'm an engineer on the accessibility team. Many people use speech synthesis across Apple platforms, and some people rely on synthesizer voices. These voices are a window into their devices. Therefore, the voices they choose are often a very personal choice. People using speech synthesis on iOS can already choose from many different voices. Let's take a look at how you can provide even more. First, we'll talk about what speech synthesis markup language is, how it can bring immersive speech output to your custom voices, and why your speech provider should adopt it. Next, we'll walk through how you can implement a speech synthesis provider to bring your synthesizer and voice experiences across the device. And finally, we'll dive into personal voice. This is a new feature. Now, people can record their voice and then generate a synthesized voice from those recordings. So now you can synthesize speech with the user's own personal voice. Let's start by taking a look at SSML. SSML is a W3C standard for representing spoken text. SSML speech is represented declaratively using XML format with various tags and attributes. You can use these tags to control speech properties like rate and pitch. SSML is used in first-party synthesizers. This includes WebSpeech and WebKit and is the standard input for speech synthesizers. Let's take a look at how you can use SSML. Take this example phrase that has a pause in it. We can represent this pause in SSML. We'll start with our hello string, add our 1-second pause using an SSML break tag, and finish by speeding up nice to meet you. We do this by adding an SSML prosody tag and setting the rate attribute to 200%. Now we can take this SSML and create an AV speech utterance to speak with. Next, let's take a look at how you can implement your own speech synthesizer voices. So what is a speech synthesizer? A speech synthesizer receives some text and information about desired speech properties in the form of SSML and provides an audio representation of that text. Suppose you have a synthesizer with great new voices, and you want to bring it to iOS, macOS, and iPadOS. Speech synthesis providers allow you to implement your own speech synthesizers and voices into our platforms to give even more personalization to users beyond system voices. Let's see how this works. Speech synthesis provider audio unit extensions will be embedded in a host app and will receive speech requests in the form of SSML. The extension will be responsible for rendering audio for the SSML input and optionally returning markers indicating where words occur within those audio buffers. The system will then manage all playback for that speech request. You don't need to handle any audio session management. It's managed internally by the speech synthesis provider framework. Now that we understand what a synthesizer is, we can start to build a speech synthesizer extension. Let's start by creating a new audio unit extension app project in Xcode. Then select the speech synthesizer audio unit type and provide a 4-character subtype identifier for your synthesizer, as well as a 4-character identifier for you as a manufacturer. Audio unit extensions are the core architecture upon which speech synthesizer extensions have been built. They allow your synthesizer to run in an extension process instead of in your host app process. Our app is going to provide a simple interface for buying and selecting a voice that our extension will synthesize speech for. We'll start by creating a list view that shows our available voices for purchase. Each voice cell will show the voice name and a buy button. Next, I will populate my list with some voices. Here, WWDC voice is a simple struct holding the voice name and identifier. We also need a state variable for keeping track of purchased voices, and a new section to display them. Next, let's create a function for purchasing a voice. Here, we can add the newly purchased voice to our list and update our UI accordingly. Take note of the AV speech synthesis provider voice method, update speech voices. That is how your app can signal that the set of available voices for your synthesizer has changed, and the system voice list should be rebuilt. In our example, we can make this call after completing an in-app purchase for a voice. We also need a way to keep tabs on which voices are available in our speech synthesizer extension. This can be done by creating an instance of user defaults that will be shared through an app group. An app group will allow us to share this voice list between our host app and our extension. We are explicitly specifying a suite name that we provided when creating the app group. This ensures the host app and extension read from the same domain. Taking a look back at the purchase function, I have implemented a method to update my user defaults when a new voice is purchased. AV Speech Synthesizer also has new API to listen for a change in available system voices. The set of system voices can change when a user deletes a voice or downloads a new one. You can subscribe to the Available Voices Did Change notification to update your list of voices based on these changes. Now that our host app is done, let's fill in the audio unit, which consists of 4 key components. The first thing we'll need to add is some way to inform the system of what voices our synthesizer will provide. This is accomplished by overriding the speech voices getter to provide a list of voices, and reading from our app group user defaults domain we specified earlier. For each item in our voice list, we'll construct a US English AV speech synthesis provider voice. Next, we need some way for the system to tell the synthesizer what text to synthesize. The synthesize speech request method will be called when the system wants to signal to an extension that it should start synthesizing some text. The argument to this method will be an instance of AV speech synthesis provider request containing SSML and which voice to speak with. Next, I'll call a helper method I've created in my speech engine implementation. In this example, my getAudioBuffer method will generate audio data based on the voice specified in the request and the SSML input. We also set an instance variable called framePosition to 0 in order to keep track of how many frames we've rendered as the render block is called, and we copy frames out of the buffer. The system also needs a way to signal to a synthesizer to stop synthesizing audio and discard the current speech request. This is accomplished with cancel speech request, where we will simply discard the current buffer. Finally, we need to implement the render block. The render block is called by the system with a desired frame count. The audio unit is then responsible for filling the requested number of frames into the output audio buffer. Next, we will set ourselves up with a reference to the target buffer and the buffer we generated and stored earlier during the synthesize speech request call. Then we'll copy the frames into the target buffer. And then finally, once the audio unit has exhausted all the buffers for the current speech request, the action flags argument should be set to offline unit render action complete to signal to the system that rendering has completed and there are no more audio buffers to be rendered. Let's see it in action. This is my speech synthesizer app. I will purchase a voice and navigate to a view where I can synthesize speech using my new voice and speech engine. First, I will give the synthesizer an input of hello.
Hello.
Then I'll give the input goodbye.
Goodbye.
We've now implemented a synthesis provider and created a hosting app that provides voices you can use across the system, from VoiceOver to your own apps. We can't wait to see what new voices and text-to-speech experiences you craft using these APIs. Let's move on and talk about a new feature called Personal Voice. People can now record and recreate their voice on iOS and macOS using the power of their device. Your personal voice is generated on the device and not on a server. This voice will appear amongst the rest of the system voices and can be used with a new feature called Live Speech. Live Speech is a type-to-speak feature on iOS, iPadOS, macOS, and watchOS that lets a person synthesize speech with their own voice on the fly. You can request access to synthesize speech with these voices using a new request authorization API for personal voice. Keep in mind that usage of personal voice is sensitive and should be primarily used for augmentative or alternative communication apps. Let's check out an AAC app I've made to use personal voice. My app has 2 buttons that will speak common phrases I find myself saying at WWDC, and a button for requesting access to use personal voice. Authorization can be requested with a new API called Request Personal Voice Authorization on AV Speech Synthesizer. Once authorized, personal voices will appear alongside system voices and the AV Speech Synthesis Voice API, Speech Voices, and will be denoted with a new voice trait called isPersonalVoice. Now that I have access to personal voice, I can use it to speak with. Let's check out a demo of personal voice in action. First, I'll tap the Use Personal Voice button to request authorization. And once authorized, I can tap a symbol to hear my voice.
Hi, my name is Grant. Welcome to WWDC 23.
Isn't that amazing? And now you can use these voices in your apps too. Now that we discussed SSML, you should use it to standardize speech input and build a rich speech experience in your apps. We also walked through how to implement your speech synthesizer into Apple platforms. So now you can provide great new speech voices that people can use across the system. And finally, with personal voice, you can bring even more of a personal touch to synthesis in your apps, especially for people who may be at risk of losing their own voice. We are super excited to see what experiences you create using these APIs. Thanks for watching.